the lecture is going to be on application development and review?
Yeah, application development and review. Now, it's August 10th, right? So we're way over here. We have, after this week, we have 3 weeks to go. And I'll let, you know, if, I'll just take questions now, or, you know, whatever you want to look at. You got an idea what to do?
Yeah, I'm just loading everything up right now.
All right.
Can we see another example of the classes?
Talk about classes?
Yeah.
You want to look at, do you have any code you want me to look at?
I haven't done it yet. But like,
Haven't done it yet?
No.
See, I got to tell you, it's hard because I gave a lecture on this.
yeah, I remember.
So you got to do a little bit to struggle with it and whatnot, you know. So if you, the more you delay, the less deep your understanding and competency is going to be. So you got to really dive in there and start tinkering with this. And then when I talk about it, after having gone through that experience, you're going to get a lot more out of it. So, does anybody have code from these assignments that you want to look at?
There's only 2 questions, right?
Yeah, rectangle class and number class, but then there's also the example quiz questions. A bean jar, egg carton, because the answers are there. We looked at this point class, right? And there's nothing in point.h. Now we create an instance of our user-defined data type, our class. This is the no argument constructor. And normally, you would use parentheses to show that there's no arguments being passed in. But in this language, C++, we omit the parentheses when we create an instance of a class with no, you know, constructor arguments. It's different than the other languages. Then we have, you know, we can, once we have this P1, this point object, then we can call the functions that are in that class. So set x and set y. So this P1 is a point, so it has an x and y coordinate. We can modify those by passing in new values for them, for the x coordinate and the y coordinate, by calling these setter methods, set x and set y. And then we can call other functions, like the distance from the origin. So we've got a P1, it's at 0, 3, and we want to know it's the distance from the origin, which should be 3. And so we can use that in a test. We call distance from origin on P1 and compare the result to 3. And here we have another point, P2. This time, instead of using the setter methods to set the xy coordinates to what we want, we pass the xy coordinates in through the constructor. So there, you've got 2 different constructors. This is the no argument constructor. This is the constructor that takes 2 doubles. First double represents the x coordinate, that would be 4. The second double represents the y coordinate, that would be 0 here. And now the distance, well, then we have another function that we're going to look at. It's not the distance from the origin, it's the distance from another point. Of course, what other point? So P1, we want to know the distance from a from P1, or I guess to P1, from some other point. But what other point? So that's the information that's passed into the function. So we get P1.distance from P2. What is the distance? You see how it's the names that we're picking makes it a little easier to read. What is the distance from, what is the distance to P1? No, wait a minute. Yeah, what is the distance from P1, from P2 to P1? And so here, x would be at 4. Y is at 3. That's a 3, 4, 5 right triangle, so it's going to return a 5 for that. And it's a little tricky to use equality here because, there's, in the computer, you don't represent real numbers. You can't represent all real numbers. So like you can't represent pi. Because pi has an infinite, in our representation system, using say decimal notation, pi requires an infinite number of symbols to represent. So we can refer to it, with the Greek letter pi and say, well, there's one symbol. Okay, that's good. But to represent it using the decimal digits, or binary digits, we can't represent it precisely with a finite string of symbols. So they're going to get approximations of values that are stored in memory. So when you work with doubles, and then it's not a good idea to use ordinary equality here because of the potential for I guess you can call it round-off errors. But this is working in our case. Here's another form of the constructor which I've never used before. This is the newer version of C++. So we can use this form of the constructor with that assignment operation. And what it does is when the compiler looks at this syntax, this expression, it says, oh, you're assigning a single value. You're providing a single value 9 to be used in the initialization of a new point instance. So if you just think about it logically, well, that means it's a constructor, or the constructor for the point class that takes a single value. So we define several constructors for the point class, one that takes no values, one that takes only the x coordinate, one that takes both the x and y coordinate, which we use here. So these are 3 different constructor invocations. It's for the same class, so we can construct instances of the class using different constructors. You can have multiple constructors. And you distinguish between the constructors just by the arguments, that's all. The constructor that's being called in line 16 just takes a single argument, the x value. And that would be, I think it's in this material here. Here's the point class. And let's see, this is our implementation. So we're implementing distance from origin and distance from another point. So we've provided 2 function implementations. So that means we don't want those to be implemented here. Otherwise, we get redefinition error. And that should do it right there. We don't need this. We don't need this. Now to compile this code, well, it's point main actually. That's not good enough. We have to provide the two files that contain, functions that need to be compiled. So two files on the command line for the compiler. That seems to run all right. All tests passed. So, this assertion passed, this one passed, these passed here, and this one passed. Oh, so here we're showing a pointer. This is how to, now this is not going to be on any test or in any assignment, but I'll just show this to you anyway. P4 was created in line 16. P4 refers to a point instance, a point object. They also use the word object. So it's, it has some, P4 refers to some allocation of memory that stores the data that describes this particular instance P4. So there's going to be a 9 and a 0 inside the memory. This would be inside RAM. So this ampersand here we've seen ampersand as a symbol used already to specify reference parameters in functions. But that's not what the ampersand means here. Here, the ampersand means something else. It refers to an operation. An operation, returns something. This is the address of operation. So ampersand before P4 is read as address of P4. The address of P4. An address means what byte number does P in memory, and so P4 will be stored in memory, in RAM. And each byte in RAM has a number. There's the first byte, 0, the second byte, with address 1, and so on. So this ampersand in front of the variable name tells the compiler that we want, at this point here, you want this expression to evaluate to an address, which is an integer. Computer addresses are integers, byte numbers. And we're going to take this address and assign it, this equal sign here, so we're going to assign it to this variable PTR, which is short for pointer. So pointer is a variable. So remember, when we declare a variable, we have to tell what its type is. So we could have declared pointer as an int. I mean, that would make sense, right? Because byte addresses are integers, essentially. But the compiler won't let us store that into an int. It's going to say, no, that's not the right data type for an int. An int is not the right data type for an address, even though internally that's the same thing. It's an address is an integer. So we want to tell the compiler that this PTR variable is a pointer to instances of point. And that's what this notation is. Here, we're telling the compiler that P4 is a point instance. Here, we're telling the compiler that PTR is not a point instance, it's a pointer to a point instance. Here, P4 is a reference to the point instance data itself. PTR here is a reference to a memory address. It's a reference to data, to storage in RAM. PTR here is a reference to RAM storage on a 64-bit machine. PTR is a reference to 8 bytes, contiguous bytes of memory. And in those 8 bytes is the address of a point instance in RAM as well. So inside RAM, we have these bytes which store a RAM address. So which is a reference to another storage area in RAM. So this is used heavily in C and C++, these pointers. And actually, all languages, this is an issue. You have to think about that. So as the computer, as the CPU runs and operations are performed, what you're working with in many cases is not the data directly, it's the pointer to the data. And sometimes you work with pointers that point to pointers that point to data. And that's very common, pointers to data. So anyway, this is the notation. This is the address of operator. And this is a part of the type definition. It says that PTR is a pointer to instances of type point. And now, when you have a pointer variable, PTR, you don't use the dot notation like you do with a ordinary reference. Like P4 here is an ordinary reference, so we use the dot notation. But when you have a pointer, which is a reference to an address, then you use this dash greater than symbol. It looks like an arrow. That's how you dereference a pointer. So this tells the compiler, hey, I want to execute the getX function on the point instance that PTR points to. I'm going to repeat that again a little differently. I want to execute the getX function on the pointer instance with memory address stored in the variable PTR. And of course that should return a 9 because we set it here. So P4 is an ordinary reference to the point data, and PTR is the memory address of that data. It's not a direct reference to the data, it's a reference to a number in memory that is the address of the data. So P4 and PTR, they both are ways of referring to the same point instance. They're just two different ways of naming the same point object or point instance. Anything else you want to talk about with the classes? Once again, I got to tell you, if you're not practicing, it's not going to mean much. I can just sit up here and talk, and you're going to go, yeah, no, that's good. But you got to do this. It's all about getting your hands dirty and coding things and trying to be a little creative as well, if you can. And that's how you gain your skill and your competency. Yeah.
Can you take a look at my code for the classes on exercise 2?
Yeah, let's take a look at yours. All right, you got to help me find you again. Oh, it's not in this list. Hold on. This one? Oh, you are the up here. I always confuse you with this one, don't I? Sorry. Okay. Exercise 2
Classes.
in classes. I'm going to just kill that. So this is the classes folder, exercise 2. Number class. So here's the UML class diagram, Unified Modeling Language. That's a set of different kinds of diagrams. There's one particular type of diagram in that UML system. They're called the class diagram. So you have a single member variable n, which is an int. It's private. That's what the minus sign means. So code outside of the class functions is it cannot access n directly. That's what private means.
So if we have that kind of diagram that has a minus sign, that's private, and if it has a plus, it's public.
And plus is public, exactly. That's why you look down here, see the public? Oh, you have n in the public section. You got to create a private. Can you create a private section right after here? Create a private section, put the n down there. Good, that's it. That's how you do it. So now we got this in n. That's correct. And then we have these 4 public functions. So one of them is a constructor. We know it's a constructor because it has the same name as the class. The name of the class is number, but the constructor name must be number as well. So I see that you have no constructor defined. So why don't you add a constructor that takes a single argument n as an integer? Can you do that? Yeah, that's a good place. Now, the constructor function has no return type. So you don't put void in front of it, you don't put bool in front of it, just give the name of the function, number. So that would just be number, N-U-M-B-E-R, yeah. And then now after the name of the function, just like the other function, see this function? After the function name, you have the parentheses and then the arguments. So you got to do that too. There you go. That's it right there. Now, see this semicolon here without the braces, without the curly braces, it means that we're going to define the constructor elsewhere. That's what set value means. This semicolon without the braces in there, without a function body, it's telling the compiler that set value will be defined later. Now, isPrime function is different. You have the braces, you have a function implementation. Can you indent this line 31 for me? No, that should be indented. There you go. The same with 35. Those should be fully indented. All right, so isPrime has what they call an inline definition. You know, we declare it here inside the class declaration, but then we go ahead and implement it. You know, we're not telling the compiler like we did with set value that we're going to implement it later. We're going to implement it now. So if you look down here, I see that you don't have these other functions implemented. So you'll need to add their implementation here, or else add their implementation down in there. So let's see what I asked in the question. Maybe I specified something specific for that. This is the number class, right? So I don't say how to implement it here. So you can implement it your way. How do you want to do that? You want to do an implementation up here like isPrime and isLucky, or do you want to put the implementation external? Well, to be consistent, you know, you'd make it inline, right? So to be consistent, let's implement those inline.
So
All right, no, I changed my mind. Let's put the implementations down following this class declaration block. See this block here, and it ends with a semicolon? Let's put the implementation down here. So what we do is we just list the function, with its input arguments. That'll be number, parenthesis, int n. And then open close parentheses, open close braces rather. There you go. That's kind of a stub there, right? And so now we got to fill in its implementation. Maybe you want to put a blank line above and below that function just to separate it. Yeah, there you go. And above it, above as well. Yeah. All right, now one other thing. When the compiler sees this number, it's going to say, well, you're declaring a function, but it looks like a global function. We got to tell the compiler that it's the function in the number class. So you use the class name followed by 2 colons. So it's number, colon, colon, number. You want to try that? Number, colon, colon. No. On line 41. What we have to do is qualify the function name. We have to tell the compiler that this name, number, is a function in the number class. So it's number, colon, colon, number. There you go. That's how you do it. See that number, colon, colon? See this right here? That's like a prefix. It's attached to this name. And it's saying that this name here refers to something in the number class. It refers to a function in the number class. So this just says the name that follows is in the number class. That's how you read that. Now this function takes an integer n. So what do we do at the end? When we initialize, we're passing in an n during initialization here. We have to copy it into our member variable n. So can you do that? Just take the value n that's coming in through the constructor as an argument and assign it into the member variable n.
So just take this and put it right under 41.
So the confusion is this, the member variable is called n. And the argument to the constructor is also called n. They're given the same name. Let's change it. I'll make it easier for you here, right? Watch this. I'll change that to a k, all right? Now let's do it. We're going to assign k to n. We have to assign k to n. Can you assign k to n? Do you know what I mean? When I say n, okay, I'm going to say n. What does n refer to when I say n? Huh? Do you see an n in there anywhere? What n am I referring to? I'm saying the member variable n. The data, this n here. Not n. That's what you have to initialize. And I'm passing in the value k to set to n. Can you copy k into n? See this k. This is the argument to your function. You've got a k here. You want to copy k into n. This is simple. Does it sound tough? All right, how do you copy 3 into a variable called x? Can you type that for me? How do you copy 3 into x? What's the expression for setting x to 3? How do you set x to 3? There we go. Now, how do you copy k to n?
So
No, that's copying n to k. There we go. Not finished. That's a statement. How do you finish a statement? There we go. You don't need line 43. That doesn't serve any purpose. That's what you do. That's the constructor. The data is coming in. It's the constructor's a function, okay? When you create an instance of the number class, the constructor runs. The purpose of the constructor is to initialize the member variables. That's it. That's what the constructor does. There's one member variable, n. So how are we going to initialize n, this member variable n? We just set it to k. It's tough, right? And I got to tell you, it's not you. It's not you. It's not everybody. Everybody's totally confused. And I'm doing my best to explain it. But once again, you know, if you listen to me talk about it, I can talk about it for a million years. You're not going to get it. You got to just start doing it. It's like riding a bicycle. I can explain to you how to ride a bicycle up here. Yep. And it's not going to do, it'll do a little bit of good. But unless you start trying to ride the bike, it has very little chance of sinking in and for you to grasp its true meaning. Now, this is not a simple concept, classes and objects. You know, historically, computer languages did not have classes. They didn't have user-defined data types. And when they came along, it wasn't like everybody said, oh, wow, this is great. Let's all do it this way. No, no. Do you know what really happened when they invented classes and objects? A religious war got started. And the religious war was the ones that wanted to adopt classes in programming and against the ones that thought it was useless or confusing or didn't want to do it. And I would say that that war was decades long, decades. I mean, a long, long time. But now, look, the war is over. The war is over. Practically everybody does it like this now. All the languages have all been retrofitted. The old languages have been retrofitted with classes like PHP and Python. You know, those are languages that didn't have classes to begin with. Now they all have classes now. They all have user-defined data types. So it's not simple. So when you're struggling over this idea, look how simple it is. N equals K, right? And it's, you know, you don't have to be hard on yourself for not getting it, because for decades, professional programmers weren't getting this. They didn't get it. They said, I don't get it. I don't want to do it the old way, the simple way. I just, you know, I can write functions and loops, and I don't need this classes. But practically everybody does it like this now. Because, believe it or not, even though it's confusing to you at this moment, it helps you make your code more readable. Now, for little baby programs like in this class, it doesn't matter. But when you're talking about a system with 50,000 lines of code, that's a small system. That's a small program. On the small side, I would say, or medium size. 50,000 lines of code. How can you figure out where stuff is? How can I find, you know, the place where this happens? I mean, it's so huge that you have to have these patterns and these organization techniques that help you navigate through this massive code base. Classes helps you do that. Because look at it, point, a number. I mean, that's where you go. It's expressive. And so you've got number instances and these instances have behaviors. You invoke them using the functions. It just ultimately turns out to be a very useful set of patterns and thinking styles so that programmers can write a lot of code, keep it organized enough so that the code can be modified over time. You know, code is almost always being modified and tinkered with over time. It's never the same. You know, like Facebook. You know, Facebook, I heard that they update their system every 2 weeks. So every 2 weeks, you've got a new Facebook. But it's a lot of changes. You know, constantly changing. You know, Windows, and you get the updates on Windows. How often do you get an update in Windows? It's just constant, right? It never stays the same. So Windows, I mean, take Windows. How many lines of code is in Windows? More than, I believe it's more than 10 million. 10 million lines of code. So they're using classes. They're using this sort of organization. So I'm trying to make the point that's important, number one. And number two, I want to remind you that it took many years for programmers to adopt this approach. So don't be hard on yourself if you're not getting it, because there were professional programmers for decades that didn't get it. Maybe they didn't want to get it, and they thought about this. But you've got to start spending time with it. The sooner you get to it, the better. All right, let's take a look at the next one. What about set value? Let's go ahead and implement set value. This one, if you notice, this also doesn't have braces, unlike is prime and is lucky. So let's implement that down here, line 44 and below. Let's go ahead and implement set value now. Now remember, the compiler is going to look at that and say set value. Oh, that's just a function. No, we got to tell the compiler that set value is inside the number class. How do we do that? How do we tell the compiler how did we tell the compiler that number was in the number class? This says that set value is in the set value class. Is set value in the set value class? No, I don't think so. Set value is in the number class. It's the same as line 41. I mean, I know you tried to do the same thing, but think about it. And then set value, you look at the number class. This number, this function name, which is identical to the class name, we say it's in the number class by prefixing it with the class name. So you have to prefix set value with the class name. There you go. That tells the compiler that set value is a function in the number class. Got it? I don't think you're going to forget it now, right? You got it, right? Okay. Now, that's it. You implemented it. Line 45 is good. Now let's suppose you, in this argument here in line 44, let's suppose you use N instead of J. Maybe that's the style that your team is using. Just got hired recently, and you're working your first day here. And you notice that the team that you're working with, they use the same letter N in the set function that they do for the N that's a member variable. So just change the J to an N as in line 44. Now, how are you going to change line 45 to make that work? Equal, equal? That's comparison. Assignment is a single equal sign, not a double equal sign. So there's a conflict. We've got the member variable N and the function parameter N. So the function parameter N has more narrow scope. It's a more immediate, and so it overshadows the member variable N. So if you want to designate the member variable N, so that so I'm saying I want the member variable N not to function argument n, then you put this arrow n. Try that. This dash greater than n. There you go. Let me get rid of those spaces. The spaces are okay, but I want you to get rid of them. That's how you normally see it. Remember we were talking about pointers before and how I was using the arrow with pointers? Well, this is a pointer. This is the pointer that points to the object that we're inside of. So this is a special keyword in the language. So we want the member variable n that's associated with the object that set value is being invoked on. I know it's confusing, right? Once again, it takes time to get this. All right, now this n, that's the member variable n, not the function parameter n. You want to set the member variable n to the function argument n. So let's copy the function. Let's copy the n that's coming in as a function argument into the member variable n. Go ahead, assign the n that's coming in as an argument to the member variable n. Can you do that? Like this is a function, set value, okay, it does something. What does set value do? Can you explain that? What do you think it does? Just a guess. Well, it's getting some data. What data does it get? Well, it's getting something. What's the information that's being passed into set value? What type is it? Is it a string? Is it a double? What's the type of data that's being passed into set value? So you know the language I'm using, you're not familiar with it. Maybe you got to do more writing or reading or talking. You're talking to others, because I'm using the language of this discipline. You need to adopt that language. You need to be able to say these words like I'm saying them. Member variable n. How many times have you said or thought the phrase member variable n? Never, right? Well, you better start now. I'm giving you the language. You've got to learn these concepts, learn the English language expressions that you need to articulate and to think about. All right, what I want you to do with your cursor, I want you to show me, highlight the integer argument that's passed into the set value function. Highlight the integer argument passed into set value. No, that is not the argument passed into set value, no. That's the member variable n. That is the member variable n. Well, show me where is the function defined? Where is its activity specified? Can you show me where the set value function is defined? Where would that be? Well, just look for the word set value. Where does the word set value appear in the screen right now? Show me the place. Yeah, it appears there. Now this is not where we define set value. This is where we declare set value. So the verb declare in programming means that you're saying that something exists without telling you the details of what it is or what it does. So in line 28, we're declaring the function set value. We're giving some description about it. We're saying, well, it doesn't return anything, so it's void, and it takes an argument n, which is an integer. Show me the other place where set value, the word set value appears. Where does the word set value appear in the screen here? Yeah, down here. This is where set value is defined. Line 28, it's declared. In lines 44, 45, and 46, set value is defined. Here we provide the missing details. This is the details of what the function actually does. What are the statements that execute when the function is invoked, when control passes to this function? Now what set value is supposed to, look, set value gets an argument, right? It gets an argument n. Can you highlight that for me? The argument n that's passed into set value. Very, very good. That's the argument n passed into set value. That's the data coming into the function when the function runs. What do we do with that data? What good is it? What are we supposed to do with the n? Look at the name of the function, set the value. Set the value of this number instance. The value of the number instance is represented internally with this member variable n. See? This expression refers to the number variable n. So now we want to set the value, we want to set this member variable n to the integer that's passed into set value. Can you do that? What's confusing about that? I know it's confusing. Just tell me what it is.
Just not what you're trying to tell me to do exactly.
Oh, I want you to set the member variable n to the argument that's passed into the function. Highlight the argument that's passed into the function. Let's break it down like that. That's not the argument passed into the function. It's smaller than that. You highlighted too much. That's the function name too. This is not the argument that's passed into set value. That's the name set value. Show me the variable, the argument, the variable that represents the argument, the variable that represents the data passed into set value. Yeah, and get rid of the data type in the parentheses. Just the variable. Just highlight the variable. Okay, that is a reference to the data passed into the function. That needs to be copied into the member variable n. That needs to be assigned into the member variable n. You already have the member variable n identified in line 45. You see what you have in line 45? What does this expression refer to? Huh?
Set value.
No. Set value is a function. What I have just highlighted does not refer to the function set value. That expression that I have highlighted refers to the member variable n. That is the member variable n. It's a name. It's a name of something. And the purpose of set value is to set that value. The member variable n needs to be set to the data coming into the function. How many other people are lost on this one? It's just you, maybe. You don't get it, huh? Yeah, you got to think about it then. I'm not sure why you're not getting it. I know it's hard, okay? I know it's hard. And I'm repeating the language a lot, and I don't know. Is there anyone else who wants to give a shot at Yeah. Yeah, go ahead, go for it.
Oh, me?
Yeah.
You just said this is the arrow n equals n.
Yeah, I kind of wanted you to explain why to do that. That's what you need to do.
Oh, okay. So
That is the correct answer, okay? That's the correct answer, but,
because they're two different variables.
okay.
So you're trying to pass in the set value n inside the number variable.
Two different variables. Member variable n refers to some memory area, which is different than the memory area referred to the function argument n.
So it would work if we just change the variable to, let's say, e, and this way they're complete. They're actually two different. They're already two different variables, but they're also stated as two different variables. So it'd be the same thing, right?
That's right. Did you get it? It's hard, right? You're still lost. I know you're lost. See, this arrow, oh yeah, you got it. Except you're missing the n. This arrow n. There's the n on this arrow. It's not this arrow equals. Yeah, there you go. This arrow n has to be set to n. No. This arrow n, okay, this arrow n is set to n. That's this arrow n. Now assign n to that. No, you're trying to assign n to this arrow. I didn't say set this arrow to n. I said set this arrow n to n.
Just type equals n. Yeah.
That's setting this arrow n to n. Got it?
This arrow n, you could think of it as like e. So you're saying e equals n. It'll be something similar to that. This arrow n is its own variable. Even
Exactly.
though it's the same letter, it's a different variable.
Exactly. Let's change it. Let's change the function argument n to e. Yeah, and then fix the line 45. And no, this arrow e, no. The e is not this arrow is used for member variables, not function arguments. There you go. This arrow is used to identify the member variable, not the function argument. The function argument, you just use the name by itself. Because that has the, that's, like I'm a David, right? And you say David inside this room, we know it's me. It's not the David that's upstairs. But if we want to refer to the David upstairs, we say the David upstairs. We have to add more information to say not the David in front of you right here, the David upstairs. See, this is the N upstairs. It's the faraway N. That's the purpose of this. It's the faraway N. I want that N, not the N that we had here, which is the nearby N. But now you don't need to say, now, if there's no David in the room, and you say David, you immediately say, oh, the David upstairs. So you don't need to qualify this N anymore. You can omit this because there's no problem. Do you see? Why don't you omit that now? Just have N equals E. See, now because there's no ambiguity. There's only one N. The N over there, the member variable N. There's no function argument N anymore. Everybody has to practice this stuff a lot now to really get it. I got to tell you, once you get it, it's so simple, and you can do so much. You've really transitioned into a new world. All right, so we'll leave it at that. Now, what about main? We running out of time. Oh my gosh, all this time spent on that. Let's create an instance of the number class in line 48. let's create an instance of the number class in line 48. We'll use this constructor here. This one right there. Well, there's only one constructor. So we got to do like, and the syntax is number space, like the name of the variable. What do you want to call it? Let's call it 7, S-E-V-E-N. And then pass in a 7 to that. Yeah, parentheses 7, here we go, semicolon. Now we're creating an instance of the number class by invoking the constructor. So this code is running right here. See, that's the initialization code. So see this 7, that's 7 right there. That's what k equals. See, that's k is being set to 7 when you're calling that constructor. And then we take the k, the 7, and we copy it into n. So now it's in there. It's in the member variable n. Now so we've set the state of this number instance. So in the very next line, let's call the isPrime function. So it's 7.isPrime. They're just 7.isPrime, yeah. And then open close parentheses, because it doesn't, isPrime doesn't take any arguments. Yeah. So now that returns true if 7 is prime and false if 7 is not prime. So we can put that inside of an assertion. Because 7 is prime, right? So we can assert that 7 is prime is true. You know, assert that 7 is prime is true. Good, good. And line 49, we can delete that. We don't need that. See, line 49 doesn't do anything now. All right, now, but look at isPrime is not implemented correctly because you're just checking to see if it's even. So if n mod 2 is 0, then you're returning false. N mod 2 is 0 for even numbers. What about 9? 9 is not prime. And 9 mod 2 is not 0. So you're going to return true that 9 is prime. So the function needs to get fixed. So you got to use the loop, yeah. There you go, good. Yeah, you know how to do this one, that's good. Good job. Looks good. Yep. Oops, whoops, whoops. You want the brace. You want the brace there. Keep going. Yep, good, good. See, I can see you're definitely studying. I see that you're working because if you can do this, it means you've been putting some energy into the course. That's great. Well, you better close that brace there. See that? The for loop needs to be closed off. There you go. That's it. That's good. That's isPrime. Let's run that. Let's see if we can save that file and test it. I think that's going to succeed. I think it'll say all tests passed. Let's try that. Oh, maybe I can't see it. Let me do it. I'll do that, okay? So that's, and this is ex2.cpp. Nope, set value. It says, set value does not match any in-class number. So what's going on there? This, it says that this function doesn't match this set value here. Why are these different? Oh, look, we forgot the return type. Set value should be a void. Can you set that to returning void? Line 46. It's on line 46 there. Yeah. So the function returns void. No, not there, not there, not there. It comes before this is considered the name. It's a qualified name. There you go. That's it right there. Okay, let me try it now. Can you save that? That's good. And it worked. See, that was it. That's where you put the return type. It's before this number, this class name prefix here. Once again, it just takes practice. And let's take all tests passed. We got it. All right. Now that was tough, right? I hope that was useful. I was putting a lot of pressure on you to get that, and I was hoping that I was doing the right thing, but if I'm not, let me know. Okay, I'll ease up on you next time. Yep, is lucky. Oh, no, wait a minute. We don't need a loop there. But what's the definition of lucky? Let me see. What is lucky? This is if n is divisible by 7, that's it. We don't need a loop there, right? If n is divisible by 7, it's lucky. That's it. If n is not divisible by 7, it's not lucky. You don't need to do any looping. Unlike the prime number, we have to try all the divisors so that make sure that we don't have any divisor. So that's different. That's good. And then you'd want to have a test case for is lucky down here. This stuff is so hard to get. This is the hardest part of the class. In the past, I would say the students that understand constructors is really small. They just the whole concept of what we're doing is so abstract to most students, and they just don't get it. And I want to say that if you're one of those students that's not getting it, hang in there. I can see you're good. Like you did this code up here, you banged that out just like that. You're good enough to get this. So don't stop. Keep working on this. It'll sink in. You'll get it eventually. It'll become second nature. It's like breathing. I'll tell you, it's so easy. It's so easy for me. But when I first started doing this, I was like in your seat. I was just like you. I was totally lost. I said, what is going on here? What are all those words that guy's saying? It isn't. I think it has to do with just, I don't know. I mean, I can just say, I think, it's like language and concepts. I'm trying to convey ideas to you. And also, I didn't write the compiler. I didn't build a compiler. To really know what's going on, you should be implementing the compiler. I mean, there's always a deeper level, and why not? Well, deeper than building the compiler, you should understand how the CPU works, and machine instructions, and circuits, and digital logic, and to understand that, you got to know, electricity and magnetism, and you got to know the physics, and then physics has got all these unanswered questions underneath it. So, there's a lot of layers of understanding there, and you just reach a point. Whichever level you're working at, whichever layer of abstraction you're at, you just try to develop some kind of working models that you use to solve problems. All right, I think that's it. Anything else? I think we've finished. Question? No? You all set?
This code is running, but we'll take a look at it.
You want me to look at it?
No, it's okay.
You sure? I can pop it open right now. And I'll do it fast for you without criticizing you, because I've got to. We have to break for lab. You want me to look at it?
No, it's okay. I got it.
You got it? Okay. All right, that's it. Thanks for your willingness there to get beaten up on that problem. Really.